So this video will include how to determine the area and the length for a circle. So to begin, we will look at the area of a circle. Now on the upper left-hand corner, we have the overall equation along with a circle drawn. So the symbol, the O with the curly line through it, will represent an angle. The R's are for radius, and there are X and Y points where the lines will touch the outermost parts of the circle. To begin, when you have radians, your equation will be area equals 1/2 the O with the line through it, radius squared, my bad. And if you're given degrees, you will do area equals the degree over 360 times pi r squared. Now, it's basically just plugging in what you see and depending on what those numbers are. So if it's a degree, you'll put it over 360. And if it is just a radian, you'll plug it in to the radian spot. Now, two examples of this using one of the each different types. The first, using radians, is a sector has a radius of 12 centimeters and an angle of 3 radians. Find the arc area. Now, if we look up top again, we can imagine that this part right here is 3 radians, and the radius itself is 12 centimeters. So we're going to look at our first equation, the one for radians, and plug in 3 for radians and 12 for radius. So when we plug all our numbers in, we're going to get 12 squared, which is 144, 3 times 144, and a half of that answer. So the area is going to be 216 centimeters squared. Now, when your degree measurement is there instead of a radian, you'll put the degree, like it says right here, over 360. So the degree of this angle is 105, so we're going to do 105 over 360, and the radius is 5 centimeters. So what we're going to do is 105 over 360 times pi times 5 squared. That answer will give us area is equal to 22.9 centimeters squared. Now, similarly, there are sectors for the unit circle, and this is more just for arc length. Now, when we look at this, it's the same thing. We have the angle, and we have the radius, but this time it's not shaded in. We're just trying to determine this area, this part of the circle, so this line right here. Whereas on this one, we were determining all this shaded area. We just want the line. So the two equations that are given is for radians, length is equal to the radian times the radius. And for degrees, length is equal to degrees over 360 times 2 pi r. And this 2 pi r, you can think of that as the entire equation for the circle. So it's basically just the degree times the circle. So we're going to use the same example, only this time instead of calculating the area, we'll be calculating the length. So we have and I apologize for this, the radius of 12 centimeters and the angle of 3 radians, sorry. So we will be plugging in the radians and the radius. Again, 3 radians times the radius of 12, which is 36. And that's all we're going to do. So the length is equal to 36 centimeters. And it's not squared because it's not area. Secondly, we can use a second radius equation. It will use a different type of a radius. Whereas before we just had a 3 for the radius, this radius is pi over 4. Now what we would do is 8 is going to be the radian, or the radius. 8 is going to be the radius, and pi over 4 will be the overall radian. So we'll plug in pi over 4 for the radian and 8 for the radius, which will be equal to 6.28 miles.